Hello students, before we get into today's class, I just recall what we learnt in previous class. We learnt a division algorithm for polynomials, which is p of x is equals to g of x into q of x plus r of x, where p of x is the dividend, g of x is the divisor, q of x is the quotient, r of x is the remainder, right. This is normally true for numbers. We extended it for polynomials. If we multiply the divisor polynomial with the quotient polynomial, and if we add the remainder, we will get to the dividend polynomial, with a condition that the divisor should not be equal to 0 and the remainder should be equal to 0, or the degree of r of x should be less than degree of g of x, right. Hope you remember all these things, and we solved two problems, and I gave the remaining problems in the exercises homework yesterday. Now we are moving on to the third question in exercise 2.3. Here the question is, they have given a fourth degree polynomial and they have given two zeros of the polynomial. They asked you to obtain all the zeros of the polynomial. So here I wish to recall how many zeros a particular polynomial can have. How many zeros a particular polynomial can have? It depends on the degree of the polynomial. What is meant by degree? Degree means the highest power. Here, which is the highest power here? Here x power 4, 3, 2, 1, right. So, which is the highest power? 4. So, this is a fourth degree polynomial. So, it can have at most 4 zeros. At most means maximum it can have 4 zeros. So, here in this question they have given you a fourth degree polynomial and they have given 2 zeros. They asked you to obtain the remaining zeros. How you can obtain the remaining zeros? First of all, how many remaining zeros will be there? This polynomial will have 4 zeros. Out of 4 zeros they have given you 2 zeros. So, we need to find the remaining 2 zeros, right. Now, before getting into the problem, what is meant by 0 of a polynomial? What is meant by 0 of a polynomial? On that particular value, on that particular point, the value of the polynomial will become 0. That is called the 0 of the polynomial. I repeat, at this particular point, the value of the polynomial will become 0. That is, if we replace the x as root 5 by 3, then the entire value will become 0, right. So, not only for this polynomial, in general, what is the definition of the 0 of the polynomial? At that particular point, the value of the polynomial will become 0, right. In other terms, how we can say? We have learnt this in the previous class in the sense in 9th standard even we have learnt factor theorem, remainder theorem. Hope you remember. What does factor theorem says? Factor theorem says, if the remainder is 0, if we divide one polynomial by another and if the remainder is 0, then the polynomial divides the other exactly, or one polynomial is the factor of the other, right. This is a normal definition of a factor which we will say even for numbers. If the remainder is 0, what we will tell? That particular number is a factor of the other. For example, in the last class also I told you, if you take 24 and if I am going to divide it by 2, then how many times? 2 12s are 24. So, the remainder is 0 here. So, 2 is a factor of 24. So, if a number divides another number exactly leaving the remainder 0, then it is called a factor. The same thing we are going to extend it for polynomials. If a polynomial divide another polynomial without any remainder, then it is called a factor. Only if it is a factor, the remainder will become 0. Yes or no? Now, here they have given 2 zeros. So, the definition of a 0 says the value of the polynomial will become 0. So, indirectly it says these two are the factors. Yes or no? So, how will you find the factors? How will you write the factors using the values? This and all you have learnt in 9th class. How will you write? X minus square root of 5 by 3 is one factor, and another factor is x minus of minus square root of 5 by 3, this root is for the entire value. Hope you remember. We have done this in splitting the middle term also. I told you, from if I say x minus one particular value, this is called a factor. But from the factor, how will you obtain the value? Zeros or the root or the solution? You will equate to 0. X minus root 5 by 3 is equal to 0. So, x is equal to square root of 5 by 3. So, this is called the 0 of the polynomial. And if I write x minus of that value, this is called the factor. This is called what? Factor. This is called factor, and this is called what? Root or solution or 0. Right? If I write x minus that value, then it is called a factor. If I write x equal to that value, then it is called a root or solution or 0. When x equal to is a positive value, when you are writing it as a factor, you should write x minus, because we are bringing it to the other side. Right? So, always when you are expressing the values as factors, you should put negative sign only. Here I have put a negative sign, but again one more minus, because it is a negative root. So, what will happen here? This is x minus square root of 5 by 3, and the other one is minus into minus, it will become plus square root of 5 by 3. Now, if I multiply, what will happen? A plus b into a minus b relation. A plus b into a minus b is nothing but a square minus b square. So, x square minus square root of 5 by 3 the whole square, right, which is nothing but x square minus, this root is for entire 5 by 3. So, if I square and root will get cancelled. So, it is x square minus 5 by 3. Now, x square minus 5 by 3 is the factor of p of x. Which is p of x? I am going to take the given polynomial as p of x. I am going to take the given polynomial as p of x. I repeat the procedure what we did so long. In the question, they have given you 4th degree polynomial. They asked you to obtain all the zeros of the polynomial, but they have listed you only 2 zeros. So, what we are going to do now is, from the zeros we are going to obtain the factors. After obtaining the factors, we are going to divide the given polynomial by the factor, and we will obtain a quotient there. Using that quotient, we are going to obtain the remaining 2 zeros by splitting the middle term or any method of factorization, right. So far what we did, 2 zeros are given. From the zeros, how we can write the factor? X minus that particular value. Now, we have obtained a quadratic polynomial x square minus 5 by 3. Next, now we know this is a factor. Factor means it will divide the given polynomial exactly with remainder 0. So, we are going to divide the given polynomial p of x by this. Okay. How will you divide? 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. I am going to divide it by x square minus 5 by 3. The procedure is same. What we will do? First, take the first term of the polynomial and divide it by the first term of the divisor. So, 3x power 4, if I divide by x square, so I will get 3x square. So, 3x square will be the first term of the quotient. Now, keep multiplying each and every term of the quotient with each and every term of the divisor. 3x square into x square, what you will get? 3x power 4. 3x power 4. So, I told you write the like terms together so that you won't make mistake while subtracting, right. Next, when you multiply 3x square with 5 by 3, you will get a x square term. So, write under x square term. Plus 3 minus 5 by 3. You can do it in rough column if you find difficult to do it directly. So, 3 into minus 5 by 3. So, this 3 will get cancelled. So, you will get minus 5 x square. In between cube term we didn't get, so you can add 0. Now, we need to subtract the polynomials, minus, minus, and this is plus. these two will get cancelled. So you will get 6x cube. Plus into minus, you have to subtract and put the greater number sign. So plus 5 minus 2, you will get plus 3x square. Now bring down the next term, it is minus 10x, right. Now repeat the procedure. Divide the first term with the first term of the divisor. So 6x cube, if I divide by x square will get cancelled, so I will get 6x. So next term of the quotient is plus 6x. Now keep multiplying, you will get 6x cube, plus into minus is minus 6 into 5 by 3. 6 into 5 by 3, what you will get? 3 2s are 6, so 2 5s are 10. So you will get 10x. We are getting x term, so right below the x term. What x? Minus. Because this is plus, this is minus. So minus 10x, and I am going to subtract. We didn't get x square term, so replace it with 0. Minus, minus, plus. These two will get cancelled. So 3x square minus 10x plus 10x will get cancelled. Now bring down the next term, which is minus 5. Now repeat the procedure. Divide first term with the first term of the divisor. So 3x square, if I divide by x square, we will get just 3. So plus 3. Now keep multiplying. 3 into x square, you will get 3x square, then plus 3 into minus 5 by 3. What will happen? 3 into minus 5 by 3, 3 will get cancelled, so you will get minus 5. Just minus 5. You don't have any variable here and even here, right? So it is just minus 5. Now change the sign. This will become minus, this will become plus. So you got the remainder as 0. You should get the remainder as 0. Why? Because we know x square minus 5 by 3 is a factor of p of x, because we arrived at this quadratic polynomial from the zeros of the polynomial. From the zeros we arrived at this quadratic polynomial, therefore it is a factor. Factor means it should leave the remainder 0. If you get some other remainder, you went somewhere wrong, so it gives you a clue that you have to recheck your steps, right. So we got remainder 0, so far what we did is correct. Now the next step is what quotient we arrived at. From this quotient we are going to obtain the remaining two zeros, right. Now what is the quotient we obtained? 3x square plus 6x plus 3. So now we are going to use the division algorithm here. What does division algorithm says? The dividend is equals to divisor into the quotient plus the remainder, right? See here, the dividend is equal to divisor into the quotient plus the remainder. Now our remainder is 0. So this polynomial, how we can arrive at? By multiplying these two. So that's what I have written here. So the given polynomial is equals to dividend into the divisor into the quotient, right. Now this, from using this only we got the two zeros which is given in the question. Now we are going to factorize this to obtain the remaining two zeros. So how we can factorize this? Either you can factorize by taking the common term out, or else by going with the splitting the middle term. Before getting into splitting the middle term, you can take the common number out, which is common here, 3. So x square minus 5 by 3, let us keep it aside. Now from this I am going to take 3 common. So I will get x square plus 2x plus 1. Now factorize this. How you will factorize this? By splitting the middle term. So 1, and by multiplying you should get 1, by adding you should get 2. What is the possibility? 1 ones are only, right. So what will happen here? So I got 3 into x square minus 5 by 3. Here x square plus, instead of middle term I am going to write plus 1x plus 1x plus this one, right. Now take the first two terms and the last two terms and take the common term out. 3 into x square minus 5 by 3. If I take x common, it will become x plus 1 plus, here 1 only common, so I will get x plus 1. So which is equal to 3 into x square minus 5 by 3, and again x plus 1 is common and remaining one is x plus 1. So, we arrived at the factors now. From the factors, how you will find the zeros? Equate it to 0. X plus 1 equal to 0. So, x is equal to minus 1. So, x is equal to minus 1 we got twice. So, it has two repeated zeros, right? Hence, the four zeros of p of x are, what are the four zeros? In the question it is given root 5 by 3 minus root 5 by 3, and we obtained two more zeros. What is that? Minus 1, minus 1, minus 1 and minus 1. We have seen in the geometrical representation of zeros, right? It is not necessary all the zeros of a polynomial should be distinct. There are possibilities for the zeros to be repeated. We can have repeated zeros, repeated roots, right? So, in this problem we are having repeated roots. So, minus 1. Minus 1 we got twice. So, the other two zeros are minus 1 and minus 1. So, in the question they asked you to find the all the zeros of the given polynomial. Thus, we obtained all the zeros, right. Once again, I wish to precise the steps involved in this problem. First, in the question, understand the question properly. This is important 4-mark problem. The question, they have given you a 4th degree polynomial and they have given two zeros. They asked you to find the remaining two zeros. Only if you understand the concept, you can proceed with the problem. So, what is the definition of the zero of a polynomial? Says the value will become 0 if you substitute that point, which means the fact it is a factor of the polynomial. So, that concept we are going to use there. So, using that concept we obtained the factors using the zeros of the polynomial. After obtaining the factors, we divided the given polynomial by that factor. Then obviously we know the remainder will become 0 and we left with some quotient. Next we are going to apply the division algorithm here. What does the division algorithm says? The dividend can be obtained by multiplying the divisor with the quotient plus the remainder. So, we obtained the division, we applied the division algorithm here. Using the division algorithm, what we did, we tried to factorize the polynomials, in the sense we tried to express it as a product of its factors. How we can express, we didn't bother about this, because even if we factorize we will end up with root 5 by 3 and minus root 5 by 3, which is already given in the question. So, we don't want to bother about this. So, bother only about the newcomer, new quotient what you arrived at. So, new quotient what we did, we tried to factorize it, we tried to express it as the product of linear terms. Why we are interested in expressing it as a product of linear terms? Only then we will obtain the zeros. How we can obtain the zeros? By equating the factors to 0. Right, that is why we expressed the polynomial as the product of linear terms, then we equated to 0 to obtain the 0 of the polynomial. Thus, we obtained the two zeros. In this problem, the remaining two zeros are repeated zeros. So, we got x plus 1 into x plus 1. But it is not necessary always it should be repeated roots. In some other problem it may vary. You can get different roots. You can get different roots. Even if you get the same roots, you don't want to worry, because polynomial can have repeated roots as well, right. Thus, we listed out all the four zeros of the polynomial. Hope you understood. Still, if you have any doubts, kindly ping me up, right. Now, the next question in the exercise is, they have given you p of x, q of x, r of x. They asked you to find the g of x. On dividing this polynomial by a polynomial g of x, the quotient and the remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. Kindly read the question properly and take the values accordingly. Don't blindly assume the first one will always be quotient, the second one will always be remainder. First one will be always sum of the roots, second one will be always product of the roots. To confuse you, they may give in different order even. So, read the question properly and take the values accordingly. So in the question, first they have given you quotient, second they have given you remainder. So they asked you to find g of x. This is very easy problem. You know the relation between all these polynomials, right? So what is it? By division algorithm. So by division algorithm, what you know that p of x can be obtained by g of x into q of x plus r of x. So substitute each and every value. P of x is x cube minus 3x square plus x plus 2 equals to g of x we don't know, and what is q of x? X minus 2 plus what is your r of x? Minus 2x plus 4. Now we are interested in finding this g of x. As we do some linear exchange of values with the numbers, linear equation while we solve, no? The same way you try to solve this. So first bring this polynomial to the other side. So this is under addition operation. If you bring this polynomial to the other side, it will become subtraction. So x cube minus 3x square plus x plus 2. This minus 2x, if I bring it to the other side, it will become plus 2x. Plus 4, if I bring it to the other side, it will become minus 4, which is equals to g of x into x minus 2. Right? Now we have two x terms and two constant terms. So club together, x cube minus 3x square, x plus 2x will become plus 3x, plus 2 minus 4 will become minus 2, addition of integers, which is equals to g of x into x minus 2. Now we need only g of x. So bring this x minus 2 to the other side. This is under multiplication operation. So if you bring it to the other side, what will happen? It will become division. So here x cube minus 3x square plus 3x minus 2, you have to divide it by x minus 2. So if you divide this polynomial by x minus 2, you will come to know what is your g of x. That's what we are going to do it now. So how you will divide? The long division method, what we learnt. So divide this polynomial by x minus 2. By this time, instead of manipulating all these things, you by mind calculation, you should know what will be the terms of the quotient. So first step is divide the first term by first term. X cube, if I divide by x, what you will get? X square. Now multiply. X square into x will become x cube. X square into minus 2 will become minus 2x square. We got x square term only, so I have written here directly. Minus, and this will become plus. These two will get cancelled. Minus 3 plus 2 will become minus 1x square. Now bring down the next term, which is plus 3x. Now divide the first term by the first term. So minus x square, if I divide by plus x, you will get minus x. Right? Now if you multiply, minus x into plus x will become minus x square. Then 1x actually, so I am writing without the coefficient. 1x is nothing but x only, right? Then minus into minus, it will become plus. X into 2 is 2x. Now again change the sign, plus minus, these two will get cancelled. Plus into minus you have to subtract. 3 minus 2 is 1x, greater number sign, so it is plus. Bring down the next term, which is minus 2. So if you divide x by x, you will get 1, so it is plus 1. If I multiply 1 into x, this is x. 1 into minus 2, this is minus 2. Again if you change the sign, both will get cancelled, so the remainder is 0. So what is your g of x now? X square minus 1. So this implies g of x is equals to x square minus x plus 1. This is your another polynomial. That is, this is your divisor. Right? This is the procedure to solve this problem. They have given you 3 polynomials involved in division algorithm. They asked you to find the another polynomial. This is not the procedure only to find the divisor. This is the procedure to find any of the polynomial. So in division algorithm, we have 4 polynomials: dividend, divisor, quotient and the remainder. So in any question, they may give any 3 among these 4 polynomials. Any 3 polynomials they can give in the question, and they ask you to find the another polynomial. So in that case, you have to bring one polynomial to other side one by one and find the unknown value as we find the variable in the linear equation, right? Hope you understood. Look at the next question in exercise. Give examples of polynomials p of x, g of x, q of x and r of x which satisfy the division algorithm, and degree of p of x should be equal to degree of q of x. Degree of q of x is same as degree of r of x and degree of r of x is 0. I am going to leave it to you. You are going to give examples, but before leaving it to you, I want to give you few hints. First question, if you see, degree of p of x and degree of q of x should be equal. What is p of x here? P of x is the dividend, q of x is the quotient. So when the degree of the dividend and the quotient will be same, you should think. When it will be same? For example, if you take the previous problem which we solved, here the dividend is, see here the dividend, degree of dividend is 3 and the degree of the quotient is 2, right? So when we divide see how are we obtaining the quotient? By dividing the first term of the divisor. So even if the divisor is of degree 1, we are getting 1 less than the dividend only. The first term of the quotient is 1 degree less than the degree of the dividend. Hope you understood, right? The first term of the quotient is 1 degree less than the first term of the dividend, right? So when we will get the same degree, in x cube in the, when you will get the same x cube as the first term, when, think, when you will get, only when you divide by the constant here. Instead variable illama, if you have only constant, then only if you divide the first term by the first term of the divisor, you will get the same degree as your quotient. Hope you understood. See here I am dividing x cube by x. So we are getting x square, 1 degree less than. When you will get the same degree, only if I divide this x cube by the number which doesn't have any variable. Appo I should divide by any constant. It can be any constant which is independent of the variable. Then only this x cube will remain x cube. Then only the degree of the dividend will be same as the degree of the quotient, right? So you give an example in such a way, p of x can be any polynomial, and when you give example for g of x, when you define g of x, define a constant polynomial. Take any, for example, so you are making me to do. So p of x, if you are going to define x square plus 3, then g of x you define it as a constant polynomial. What is meant by constant polynomial? Which doesn't have any variable, say some 3. Then you find what is your q of x. Then you find what is your q of x and r of x. Then obviously you are check whether the division algorithm is satisfied, and you check whether the degree of p of x is same as the degree of q of x, right. Now if you take the second subdivision, you have to show that, second subdivision you have to show that degree of q of x is equals to degree of r of x. When the degree of the quotient will be same as degree of the remainder, it can happen in many cases. Even in the problem which we solved earlier in the same exercise, we have come across the degree of the quotient same as the degree of r of x. So you can state your own example. And the third one is degree of r of x is 0. Kindly read the question properly. Degree should be 0. They didn't mean r of x is equal to 0. R of x equal to 0 means what? The remainder should be 0. They didn't say the remainder should be completely 0. They told you degree of r of x should be 0. What is meant by degree of r of x is 0? Which means it should be the constant polynomial. It should not have any variable. So the remainder should be just a constant. It should not involve any variable. Even we have solved problems of that kind also in the same exercise. We have come across problem where the remainder is just a number without any variable, for 3, 4, 8, like that we have arrived. So you can state a problem of that kind as an example for this, right? So in today's class we have solved a few problems from exercise 2.3 and I have given you few as homework. These 3 questions are additional questions which is not there in your textbook. I have given the first 2 questions in the same model as we did, and the third one also in the same model, but you have to think little bit. Here they have given you a third degree polynomial, cubic polynomial. 2 roots are given and you need to find only the third zero. Yes, you give a try, and if you have any doubt you just contact me. Thank you, students.